Hello, everybody. My name is Rowena Vespa, and I am presenting my final project for the KaggleX showcase for time series forecasting. My project is time series forecasting using extreme gradient boost, the Arima method, and three deep neural network methods. A bit about myself. I am a machine learning enthusiast. I am right now a graduate student in data analytics and computational social science here in Boston, Massachusetts. I am a pharmacist by profession. My domain knowledge includes healthcare industry and healthcare trends. My goal is to transition into a healthcare data scientist role, and my research interest includes healthcare trends, health inequities and disparities, and identifying social determinants of health. My project is regarding time series sales forecasting using XGB regressor, the Arima method, specifically seasonal Arima method, and three different neural network models. The data source is from Kaggle, the store sales time series forecasting competition. The training data is pretty clean. It includes dates, store numbers, items, whether they're on promotions, and the unit sales of the items at a large grocery store in Ecuador. The task is to build a model that accurately predict unit sales for the thousands of items sold at the retail stores. My approach is first to understand and visualize the data. I conducted diagnostic plots, understood trends, seasonality, and noise. I experimented on different XGBoost hyperparameters. I evaluated parameters, the PDQ parameters for the Arima model. I also pre-processed the data and reshaped the data set for training for neural network models. I experimented with different neural network topologies and architectures. And my metric of measure is root mean squared error and learning curves. The first approach was to use the extreme gradient boosting for this regression problem. I did the deterministic process. The parameters I set is a frequency of monthly with a 4-season order. It's a constant of true. I fitted this model in XGB regressor. And for the test data, I did the same deterministic process for the out of sample with the 16 steps. And the result of this model is a root mean squared logarithmic error of 0.46808, which can definitely be improved. Next, I moved on to the Arima model. The diagnostic plot showed uniform variance, normal distribution, no autocorrelation. Model is a good fit to proceed to forecasting. For the forecasting, you can see that there is an upward trend. When I decompose the data, there's also seasonality as there are peaks right before year end. And you can see there is white noise. Now, for the snippet of the code I used for the validation prediction, and for the forecast. It looks like it did a good forecast, as you can see the peak right before year end of 2018. Now for the neural network models, I used the convolutional neural network, long short-term memory, and the combination CNN-LSTM. For this, I evaluated it using learning curve. I found that the learning curve of 0.0001 produced an unstable learning process. It was not efficient, but adjusted for a learning rate of 0.00001, the learning curves greatly improved. Based on the root mean squared error and the learning curves, I would say the convolutional neural network performed the best among all the three models. And I would, I like the learning curve of the test data and the validation data. These are my accomplishments during the KaggleX. And thank you so much again for the KaggleX team for allowing us to learn and develop. Thank you.